Yeah, today's class we will discuss about second quadrant chopper. First of all, before we go to the second quadrant chopper, I will just briefly revise this first quadrant chopper. What is the first quadrant chopper circuit diagram? If you recall, yeah, this one. Here, EA, where the voltage is E naught. Here the load is there. This one is the load EB, and the current direction we have taken in this direction, IA. Now, what is the first quadrant chopper is that? See here, if you draw this one, okay, if you take this as E naught and this as IA. So what we will find out in this first quadrant chopper is that what is the situation here? First quadrant chopper, you close the switch. When you close the switch, what is the voltage? E naught is EA. So E naught is EA when you close the switch. So the E naught graph, if I draw, you'll get something like this. This is during T on time. This is T on. Then after that it is 0. So you'll find out this. Okay. So with this polarity, E naught is always positive because you find out. So whether the switch is on, or whether the switch is off, whether the switch is on, whether the switch is off, whatever you get, you find out the average of this one, you will get E naught as positive only. You will get E naught as positive. Okay, so whether the switch is on, whether the switch is off, E naught is positive. Okay, similarly, what is IA? What is IA? I have taken IA direction from left side to right side. Okay, I have taken from left side to right side. See here, as I have taken from left side to right side, that is EA direction, that is IA direction. Now you tell me, when the switch is closed, what is the direction of the current? The direction of the current will be like this one. This is the direction of the current. When the switch is off, then the diode will conduct. In that case also, the direction of the current is in the from left side to right side only. It means whether the switch is on, whether the switch is off, E naught is always positive. Similarly, IA is also positive. IA positive in the sense the current is flowing from source to the load. What is the load here? Motor is the load here. So you see the direction of the current. Whether the switch is on, whether the switch is off, the direction of the current is always from source to load. This is the source. And this is the load. So the direction of the current is always from source to load. Whether the switch is on, whether the switch is off. It means IA is always positive. Okay. And E naught, what about E naught? E naught also we have drawn the waveform. E naught with this polarity, the polarity which I have taken here, this is E naught polarity. So with this polarity, E naught, okay. What is the voltage? The voltage is, if the switch is on, the voltage is positive. If the switch is off, the voltage is 0. So the average value, what is the average value of this waveform? The average value of this one is also positive. It means in this first quadrant chopper, why we are calling it as first quadrant chopper is that in this chopper, if I take E naught on y-axis, IA on x-axis, okay, if I take E naught on y-axis and IA on x-axis, you will find out the operation is always here. The operation is always here in first quadrant. That is the reason we call this as first quadrant chopper. So what is the operation you find out here? Whether the switch is on, whether the switch is off, E naught is always positive, IA is always positive. So when y-axis is positive, x-axis both are positive, this is which quadrant it is? It is first quadrant. So that's the reason that we call this chopper as first quadrant chopper. Okay. Now we will go to the second quadrant chopper, then you will understand more. Okay. I will draw a circuit diagram of second quadrant chopper. This is the circuit diagram. This is the second quadrant. So we will take the same polarity. It means same this one E naught. E naught will take like this, and the IA direction also will take in this direction. That is from source to load. Source to load. So this is the reference polarity of E naught and IA. This is the reference polarity of E naught and IA. This is EA and this is EB. Okay. This is RA. This is LA. Okay. So the reference we are taking the same. The plus, this is so plus minus is the output voltage polarity. Source to the load is the reference direction of the armature current. Okay. Now in this quadrant, in this chapter, we will see what is the operation. Okay. So first switch. This is a switch. First switch is on. Let me take the switch is on. If the switch is on, what is circuit diagram? Let me see. The circuit diagram will be something like this. If the switch is on, okay, the switch will conduct. If the switch is conducting, what will happen to the diode? You see now, okay, we'll do one thing. The diode switch is on. Okay, so the switch is on. If the switch is on, what will happen if you apply KVL in this? If you apply KVL in this, you will understand yourself that the diode becomes reverse bias. This diode becomes reverse bias because apply KVL in this, then negative voltage will be applied across the diode. So when the negative voltage is applied across the diode becomes reverse bias. So if the diode becomes reverse bias, what is circuit diagram? Equivalent circuit diagram it becomes this. The supply here is disconnected completely, something like this. Disconnected like this. So it is closed. Now you see RA, this is LA, this is EB. You can see yourself now carefully. If you can see, if the switch is closed, then what do you find out here? What do you find out is that what is the voltage here? E not. What is the voltage E not here? Let me draw. I will draw two waveforms. One waveform for E naught, another waveform for IA. Now remember, the reference direction of IA is this. This is the reference direction. Now you see yourself when the switch is on, the switch is short circuited. So what is the voltage across the switch now? The voltage across the switch is 0. So the voltage across the switch is 0. It means the E naught is 0. Till which time? Till T on. As long as the switch is on, the voltage across or the output voltage E naught is 0 because you have seen it is short circuited. The switch is on. Okay. What is the current in this direction now? What will happen to the current now? The current here you see carefully, if you observe carefully here. Okay. So what do you find out the current here is that as the switch is closed here, so before this happened, the motor is running in a particular direction. Now as the switch is closed here, you see yourself this EB is there. Okay, this EB is there. So the actual current will flow in the switch like this because the switch is closed. So the actual current will flow like this. In the sense, the current now at the reference direction of the current I have taken as from left side to right side, but actual current it is flowing. How it is flowing? It is flowing in the opposite direction. So it means negative current flows here. So when the negative current is flowing like this, so negative current starts here. So negative current starts here in the sense you will find out that the current definitely is reversed here. So how do you draw if the current is reversed here? So if the current is reversed here, you will find out. Then I will put here minus IA. I will put here minus IA because direction of the current is right. What is the direction of the current? The direction of the current gets reversed here. Simple thing to understand. As the switch is closed here, the voltage E naught is because it is short circuit. Now the question is that what is IA? So what happens to IA is that as the switch is closed, the switch conducts in this direction. So this the current in this will flow in the opposite direction. It means the waveform now I am going to draw of minus IA, not IA. So minus IA waveform, how it will be? How it will be in the sense it will be something like this. That in a steady state, what do you find out in steady state? In steady state, it's exponentially rising. So you will find out exponentially rising. So negative current will increase in this direction. Negative current will increase in this direction. Okay. Then after that T on, you open the switch now. If you open the switch, what will happen? If If you open the switch, if you open the switch, the switch is off. If the switch is on, what will happen now? You see, this is EA. Okay, so this is diode, and it is open now. You are running. Okay. Now earlier, what you find out? Earlier, you find out the current was flowing like this. When the switch is on, when the switch is on, the current was flowing like this, and it is increasing in the negative direction like this. This is one, this is another. Increasing in the negative direction like this. When it is increasing in the negative direction like this, suddenly you turn off the switch. So when you turn off the switch, suddenly what will happen is that this inductor current will force the diode to reverse. So if the diode will conduct now. So when the diode is current, why the diode current? Because the direction of the current earlier is from right side to left side. Of course, we have taken the reference direction of the current. What is the reference direction of the current? From left side to right side. But what is the actual current flowing? Actual current is flowing from right side to left side. That is, the actual current is flowing from motor to the source. Very important. So actual current is flowing from motor through the switch like this. When the switch is off, when the switch is off, voice clarity. Okay. There is network issue there. Now is it clear now? Please answer.
Okay.
Yeah. No. So, I think, okay. Now is it clear? I will try to make it as clear as possible. Yeah. Okay. Now I will repeat that. See this now. Yeah. What will happen in this second current chopper is that this is circuit diagram. First, you turn on the switch. When you turn on the switch, this is the equivalent circuit you got. In this equivalent circuit, when you turn on the switch, the output voltage E naught is across the switch here, or what is E naught here? E naught is that is going to your motor armature. So always you take here plus minus. Always you take here plus minus. So what will happen here is that now you see. Now what you have to see here is that when the switch is on, so the output voltage of the chopper is nothing but the input voltage to the motor armature. So this is your motor. Which one? RA, LA, EV is the motor. So the voltage across the switch here becomes zero because you turn on the switch. So it is short circuit. So the voltage is zero. Okay. Once you got this voltage zero, then I have drawn the waveform here. Zero voltage I have drawn here. Okay. In that case, what is the current flowing? That is the question now. What is the current flowing here is that as the switch is closed here, so the current will get reversed like this. The current will get reversed like this. So the reference direction I have taken from left side to right side, but actual current is flowing from right side to left side. So that's the reason that I am drawing the waveform of minus IA, not IA. So minus IA waveform I have drawn. Then what you find out minus IA waveform is that the current will rise in the negative direction in the exponential way till as long as T on is there. Okay. Next status is that yes,
sir,
please.
Yeah. Why we take that reverse current, sir? Is it because of EB polarity, sir?
Yeah, you can take like this. It is because of EB polarity. It is because of EB polarity. Now, what exactly happens? I will tell you that. See, before this, first of all, the second quadrant chopper is there. Why this second quadrant chopper you will use is that actually, see, we will take something like this. One example I will take. See, now the motor is running. Say for example, okay, there is a motor is there. Motor is running. So when the motor is running, so it runs in one particular direction. So when it runs in one particular direction, what you are going to do is that now you want to apply brakes. Say for example, if you apply brakes, what will happen? Please tell. If you apply brakes, what will happen? If you apply brakes, first thing is that two things will you need to understand here that if you apply brakes to the electrical motor, okay, it means you want to slow down the electrical motor. So what you do generally is that you say you will apply brakes. So even you apply brakes, what will happen to the direction of the motor? Does the direction of the motor will reverse or it will continue? It will continue in the same direction, but it will slow down. Am I correct or not? It will continue in the same direction, but it will slow down. Yes or no?
Yes, sir.
So during that time, what you do is that during that time, if you have this chopper, if you have this chopper, okay, during that time, if you have this chopper, if you use this chopper, then you have the chance. What you have the chance is that the energy which is stored in the motor, you can recollect that, or you can take that and give back to your source if you have the second quadrant chopper. So if you want to do that, see E naught is positive only or zero it is. Okay. So but what will happen here is that the current gets reversed. Why the current gets reversed here is that you can take like this because of back EMF. Back EMF in the sense, what is that back EMF actually? It is because of the rotation. It is because of the rotation. Am I correct? The back EMF is because of the rotation. So now you are slowing down that. You are slowing down the motor. So as you are slowing down the motor, what will happen is that that energy which is stored in the vehicle, mechanical energy, it will be converted and it will go back to the source. That is what will happen now. Now to understand this completely, one thing I will do. Let me complete this switch is off. When the switch is off, then I will complete that. Then you can ask the same question. Then I will explain that. Okay. So when the switch is off, what will happen now? As you have taken the direction that is from right side to left side, then it will force the diode which is there because I turn off the switch here. When I turn off the switch here, the inductor current which was there earlier from right side to left side, it will try to continue in the same direction. So it will force the diode to conduct. So when it force the diode to conduct, then what will happen is that the switch is it will be like this. It becomes forward bias. Okay, so the current flows like this. What is E naught here now? This is E naught. E naught is nothing but EA. Okay, because the diode conducts now this time. So this is RA, this is LA, this is EB. Now how the current is flowing? The current is flowing in this. So now you see what is happening here. This time this is the motor. Which is the motor here? This is the motor. This is the motor. Now this motor is giving energy back to the source. That's the direction of the current IA. You see the direction of current IA. So the direction of current IA is like this. So let me tell you now. Now the whoever asked this doubt. Now are you there?
Yes, sir.
Okay, I will tell you now. Now you see here now. See when the switch is off, and when the switch is on, you take both the cases. In both the cases, you see yourself that if you operate the second quadrant chopper as the diode is in this direction. For example, you do one thing that yeah, please see here. Sorry for the disturbance. Okay, in between. Okay, so you please see here now. What you need to understand here is that see the switch is on and the switch is off. You have two possible cases. If you think that, just imagine yourself that if you think that if you don't have this chopper, if you don't have this arrangement, the current in the motor cannot get reversed because the diode, you see what is the direction of the diode here. This is cathode, this is anode. So when this is cathode, this is anode, what is the only way it conducts? The only way it conducts is from right side to left side. This is the only way it conducts. So when it is conducting right side to left side in one case, then what is the, so in that case the inductor current also flows in the right side to left side only. Then the other case in the sense the switch is off, in the sense the other case is switch is on. So you take both the possibilities. If you take both the possibilities, you will see that what you will see here is that the direction of the current is from right side to left side only. You can take this reason as this back EMF. Back EMF is the reason. You can take this as the reason. Yes, you understand? Yes, are you there?
Would you explain once again, sir?
Okay, once again I will explain. Please listen now. Okay. Yeah. First of all, see the switch is on. Okay. When the switch is on, okay, you see yourself when the switch is on, what is the only way the switch conducts? First, you see what is the only way the switch conducts if the switch is on. It cannot conduct from source to the switch. Am I correct? Why it cannot connect from source to switch? Because the diode is reverse bias. Diode cannot allow to conduct from source to the switch. Is it correct?
Yes, sir.
Okay, then what is the only direction it has now? It has only direction that it has to conduct, it has to take current from motor to the switch. Am I correct or not?
Yes, sir.
Yeah, this will, when this will happen, let me tell you, when do you operate this chopper is that you don't operate the chopper when the motor is running as in the motoring mode. See, when the machine is running in the motoring mode, you don't operate the chopper number 2. That is, you don't operate second quadrant chopper. See, let me tell you, the second quadrant chopper which I am explaining now, the second quadrant chopper, this is possible, or this is possible only when you want to apply brakes to the motor, or only when you want to extract energy from the motor. In that case only you will operate the second quadrant chopper. You understand now?
Yes, sir.
Okay.
Oh,
So the motor is running. Actually, the motor is running. You can take assumption like this, that before you operate second quadrant chopper, I'm telling you the history before this second quadrant chopper. So before this second quadrant chopper, what is happening is that motor is running. Motor is running as a motor. It means the machine is running as a motor. So machine is running as a motor in the sense what? The motor is taking energy from the source. That's a meaning. That's what I mean. Now, what you want to operate is that you want to operate this motor as a generator. Generator in the sense, what you want to operate is that you want the motor to give the energy back to the source. That is your intention now. So why your intention is like that is that now you are going to apply brakes, or you want to slow down the motor. That is your intention. So when you are slowing down the motor, you have two options. What are the two options? One option is that either you can collect the energy when you are slowing down the motor. Either you can collect the mechanical energy and you can send to that source. That is one option. The second option is that you can the mechanical energy, you can allow it to dissipate as heat. These are the two options you have left. But when you use the second chopper, what is advantage? Second quadrant chopper, what is advantage is that the mechanical energy which is there in the motor, you can collect as it to the source. You can collect back. That is advantage. So to allow this advantage happen, you design the second quadrant chopper like this. When you design the second quadrant chopper like this, you see the possibilities yourself. What are the possibilities now? When the switch is on, how the switch conducts? That's the question. Whether the switch conducts, what is the possibility that it conducts? What is the possibility it has now? It has only one possibility. For example, you think the current is flowing like this. Just take assumption that the current is flowing from left side to right side. Then when the switch is off, will the current continue in the same direction? No, it cannot continue in the same direction. Why it cannot continue? Because there is a diode is there. There is a diode is there. So this diode will not allow the current to flow from cathode to anode. Am I correct or not? So the design is like that. Okay. So what is happening here is that this is happen when you apply brake. I will write here. Okay. Apply brakes. So when you apply brakes, then only you will take the help of the second quadrant chopper. It's something like this, that you will do this simultaneously. That what you do here is that when you want to apply brakes, what you do is that you operate the chopper in the second quadrant. You operate the chopper in the second quadrant. Why do you do like that? Because if you do like that, what is the advantage is that the energy which is there in the motor, that is the mechanical energy, you can take it back. You can take it back. That is the advantage. Why you operate. So see, let me tell you one thing. We are studying about the chopper. So first quadrant chopper, last class we have studied. Okay, now second quadrant chopper we will study now. Now we will study the fourth quadrant chopper also. So actually you will use the fourth quadrant chopper, not the first quadrant, not the second quadrant. You generally use the fourth quadrant chopper in the motors. See why you are using the chopper now? I told you already that you will use the chopper to control the DC motor, separately, etc. Series motor or shunt motor, any motor. You want to control the motor with the help of the chopper. So chopper is one of the options. Like last class or previous classes, I told you that rectifiers also there, AC voltage controls are there, sorry, inverters also there. Okay, so you are some resistors also there. Using anything, you can control your motor. One of the options is chopper. Now in this chopper you have several types of chopper. Now the first quadrant I'm explaining, second quadrant, but actually you don't use the first quadrant chopper exclusively. No, you always use four quadrant chopper. Wherever you want a chopper operation to a motor, you use four quadrant of chopper, not the first quadrant chopper, not the second quadrant chopper. I'm just individually explaining the each quadrant chopper. So when I explain the fourth quadrant chopper, then you will understand why it is so. So at the time being, what you must understand here is that before you use the second quadrant chopper, you will assume that The DC machine, the DC machine is running in forward direction, forward direction, direction as motor. So before you use the second quadrant, before you use, I told you already that you generally use the four quadrant choppers. What you do generally is that you will switch from one quadrant to other quadrant. This is what happens. Automatically it happens whenever you want to change the. So when do you change in the sense? It also depends once again. When do you change in the sense? For example, you want to use the machine as a motor, then you try to operate in the first quadrant. For example, you want to collect the energy back, then you go for second quadrant, or third
Yes.
quadrant, or fourth quadrant. Like this, you will switch from one quadrant to other quadrant. Yes, please tell me.
So before switching to second quadrant, is EA becomes zero, sir.
Yeah.
If we remove,
Which EA? This
yes,
EA
yes, power supply.
supply voltage you are
Yes, sir.
saying? No, no, it won't become zero. It won't become zero. It won't become zero. See, power supply will be there. See what is there. I'll tell you here. See this. Okay. So this is a source EA, for example. Okay. You need always source and you need a motor. I won't say motor. I will say DC machine better because the DC machine can be used as a motor or it can be used as a generator. Now you see. Now in between this you have a box like this. I will tell you. So this I am saying that it is a four quadrant chopper. I will say like this. Okay. Now you see. Now now for example your application. Now always remember now this is entirely inside the vehicle. This is entirely inside the vehicle. Say for example this is entirely inside the vehicle. Now you have a customer here. Now what is the customer wants now is that the customer, see here, the customer what he wants is that now he wants to speed up the machine, or he want to use this as a motor. He want to travel to some distance. So it means what he generally does, what he generally does is that he want to run this machine as motor. He want to run this as motor. That is the only option. Then what will happen is that this source will give energy to the DC machine. So electrical energy will flow in this direction from left side to right side. From left side to right side, electrical energy will flow through the chopper. Now what you do is now when the customer wants to change, or he wants this machine as a motor, then this four quadrant chopper you will just program such a way that this four quadrant chopper will enter into quadrant number one. It will enter into quadrant number one. When it enters into quadrant number one, you have seen yourself. What is the quadrant number one? This is E naught, this is IA. What is E naught? What is IA? E naught is the voltage to the motor, and IA is the current into the motor. So you will operate in this direction. Which direction? In the first quadrant you will operate. So when you operate first quadrant, what is the power here? Power is positive. Power is positive in the sense what? This machine is taking electrical power. It means it is acting as motor. Simple. Now after some time, okay, now you are traveling and you are going. So at certain distance you want to slow down. Say for example the customer wants to slow down. When the customer wants to slow down, you tell me yourself, when you are driving a four wheeler, you want to slow down. What do you do generally? You apply brakes. You apply mechanical brakes. I will tell you, you will apply mechanical brakes. So when you apply mechanical brakes, what will happen now? What will happen is that before you apply brakes, the vehicles are running with some kinetic energy. It has these wheels are have some kinetic energy. Now when you apply brakes, where this kinetic energy goes generally, when you apply mechanical brakes, this kinetic energy will dissipate as heat. Am I correct or not? It will dissipate as heat. Yes or no?
Yes, sir. Sir,
Okay.
as
Now,
we
yeah, please tell.
in electrical braking, we reduce some power supply to decrease the speed, no, sir.
Yeah, I will tell you now. This is mechanical braking. Now, as you are using a chopper and as you are applying the electrical brakes, if you apply electrical brakes, what will happen is that this four quadrant chopper is there, so it will automatically, okay, it will automatically trigger, or it will automatically switch to second quadrant. See, when it switch to second quadrant, you see what is there in the second quadrant. You please tell. E naught is positive. Your E naught is positive, and whereas IA becomes how much now? IA becomes negative. Yes, sir. In the second quadrant. So what is the advantage? I will tell you. What is the advantage is that you tell me yourself. When you switch to second quadrant, first thing is that whether your requirement is met or not. What is your requirement? You want to slow down. You want to slow down. So whether this is happening here or not? Why it is happening? Yes, it is happening. How can I say it is happening? Because in the second quadrant, what is the power? Power is negative. So power is negative in the sense, what does that mean? Power is negative in the sense, this time this DC machine is giving the power back to source. So the power is flowing now in the opposite direction. You see here, because you are operating in the second quadrant, E naught is positive, IA is negative. So it means power is negative. So power is negative in the sense, what? DC machine is giving the power back to the source. So when it is giving back to the source, when it is giving the power back to the source, what will happen to its kinetic energy? Will you please tell? The kinetic energy will decrease or not? The kinetic energy will decrease or not, because you are giving the energy back to your source. Am I correct or not?
Yes, sir.
Yeah, so when the power is going back, how do you say when the power is going back? Because you switch the four quadrant chopper to second quadrant. When you switch the four quadrant chopper to the second quadrant, then in the second quadrant E naught is positive. It means the wheels are moving in the same direction. The wheels did not get reversed. Please remember this one. The wheels did not get reversed. The wheels are moving in the same direction. So as the wheels are moving in the same direction, your E naught is positive only. But as you are giving the power back, what is the only option left now? IA should become negative. Then only it gives the power back. So E naught should be positive, IA should be negative. Then only the power it will give back the source and it will slow down. So your requirement is that you want to slow down the motor. Yes, you can slow down the motor, but at the same time, what is the advantage you are getting here? At the same time, what is the advantage you are getting is that unlike mechanical braking, unlike mechanical braking, where there is heat dissipation, the kinetic energy which is there, it is dissipating as heat here. Unlike this here, if you apply electrical braking, then what is the advantage is that this machine will give the power back to the source. That's the advantage. So you are slowing down, at the same time you are collecting the energy back to the source. That's the advantage. So in that case, this four quadrant chopper will switch to quadrant number 2. If it switch to quadrant number 2, then only your two advantage. What are the two? Not advantage. What is the requirement? Slowing down. Slowing down. You are meeting this. You are meeting this requirement at the same time with one advantage. What is the advantage? At the same time with one advantage. What is the advantage? The advantage is that collecting power from motor. So you want to slow down. Yes, you can slow down. But what is the advantage if you
Sir, connection got lost.
advantage? The only option left is that you switch the four quadrant chopper to the second quadrant. That is the only option left. So that is the reason that you design the four quadrant chopper like this. That there is a diode is there, there is a switch is there in this fashion only. Now please ask now.
Sir, in order to turn on the diode in the forward bias, EB must be greater than EA, no, sir?
Which EB? Oh, this you
Back
are saying
end.
EB? Yeah,
Yes, sir.
yeah, I understood. Yeah, that's correct. Not
And
only EB. Yeah, I understood. Now I will explain. I will explain this. EB, actually EB is not greater than EA. First thing you must understand. Okay. I will tell you how it is now. See here, where is the diode now? Diode is here. Yes, please see this now, diode here. So you have to measure the voltage here. You have to measure the voltage here. Okay. You have to measure. So when you measure the voltage here, EB is this voltage is there. There is another voltage across this inductor. Am I correct? There is a voltage across the inductor here.
yes,
Yes.
sir. Yes, sir.
Yeah. So this voltage plus this voltage, when you add both these voltages, inductor voltage and EB voltage, then it will be more than EA. That's it now. Are you convinced now with this?
Yes, sir. Yes.
So in that case, diode becomes forward bias or not?
Yes, sir. Forward bias.
Yeah. So the same thing I'm explaining here, that the inductor current or inductor energy will force the diode to conduct. How you are saying in another words, you can say like this, that the inductor it has some voltage and plus your back EMF is there. So both the voltages are there. Definitely both sum of the voltages will be more than EA. So the diode will become forward bias. Now, are you convinced now with this?
Yes, sir. Sir, can we say
Okay.
in this way, sir? Our torque
Yeah.
is directly proportional to current then? as current get reversed and torque get reversed, so it gets slowed down.
Slow down. Yes, correct. Yes, correct. Yes, correct. So,
Okay.
yes, you can say like this, that actually the motor is running in one particular direction, say for example clockwise direction. So as the current gets reversed, yes, we can say like this, as the current gets reversed, so the electromagnetic torque will get reversed. So when the electromagnetic torque gets reversed, then the load torque which is there, so both in opposite direction. So when both in opposite direction, so obviously the load torque, you cannot say load torque, obviously the resultant torque on the wheels will be less. So as the resultant torque on the wheels will be less, so the wheels will slow down. That's, we can say like this. Yes, the same way you can say like this. Okay.
Yes, yes, sir.
Okay. Okay. So with this, okay, with this, you see now what is next is that, see, after T and I said we discuss about the switch off. So switch off case. So when the switch is off, now you tell me when the switch is off, what is the voltage here? What is the voltage across the now? Can I say this is EA? See, because when the switch is off, this diode becomes forward bias. When the diode is short circuited, what is the voltage here? If it is short circuited, this is short circuit now. The voltage here is E naught is equal to EA. Can I write like this in ideal case? In ideal case, can I say like this, that EA is equal or E naught is equal to EA? So after T on, that is when the switch is off, I will write here this height is EA. Just apply KVL, then you will understand yourself that E naught is equal to EA. So I will write here E naught is equal to EA. Then what will happen now? E naught is equal to EA. So till it is till which point? As long as the complete one cycle. So this is on. Now this is during off. So during off, the output voltage is EA. During on, the output voltage is 0. Now you see yourself. What is the average voltage? What is it positive or negative average voltage here? The average voltage here is positive. You see yourself. The average voltage is positive. Okay. Now what about the current here now? When the switch is off, the diode will be forced and to be forward biased. So the current will continue through the source now. So when the current is continuing through the source, then this source will force the inductor current to decrease. You will find out like this. Of course, everything is in the negative direction, that is from right side to left side only. So you will find out like this. So the current will rise when the switch is on, the current will fall when the switch is off. This you will find out. So rising, rising, falling. You will find out like this. Now you see yourself. E naught is always positive. You check yourself. This is 0, this is positive, 0, positive. So E naught is always positive. Whereas IA is always negative. You see yourself. I have drawn the waveform for minus IA because the current has totally get reversed in both the switch is on, switch is off. The current is always from right side to left side only. So whether the switch is on, whether the switch is off, the current is from right side to left side. Whereas the conventional direction which we have taken is from left side to right side. That is, the conventional direction is from source to the motor. But the current in this case, what we have find out, it is motor to source. So the current is always negative. Current is always negative, whereas the voltage is always positive. So then it is which quadrant in that case now? Definitely you can understand yourself, it is second quadrant. You see now, it is second quadrant. So it is called as second quadrant chopper. It is called as second quadrant. So last class we have seen the first quadrant chopper. Now this is second quadrant chopper. So how do we say it is first quadrant and second quadrant in this sense? It depends on the polarity of the E naught and IA. So if E naught IA both are positive, it is first quadrant. Now in this particular case, you see yourself that it is E naught is positive, whereas IA is always negative. So then it is a second quadrant chopper. So what is the advantage in the second quadrant chopper is that, what is advantage? So and remember now, it's not like that you can operate the motor, you can operate the machine. It's not like that. Whenever you want to operate in first quadrant, you operate in the first quadrant. Whenever you want to operate in the second quadrant, you want, no, it's not like that. See here, the selection of the quadrant is also, it depends upon the customer. It depends on the customer in the sense, customer wants to speed up the vehicle. So when the customer wants to speed up the vehicle, you definitely have to operate in the first quadrant. Whereas customer wants to slow down, then you it's better you operate in the second quadrant. If you want to slow down, why? If you operate in the second quadrant, whenever the customer wants to slow down, the advantage is that you can collect the kinetic energy of the vehicle back to the source. That's the advantage. Okay, so the operation of the chopper, whether it is first or second or third or fourth, it depends upon the application. It depends upon the customer requirement. It's not like randomly, or it's not like our choice. It depends on the customer. Okay? So this is about the second quadrant. Now we will go to the fourth quadrant. Directly I will tell you. I will explain the fourth quadrant chopper, so that in the fourth quadrant chopper I will explain all the four modes. Okay. So Now this is EA. D1, D2. Okay. So here is your motor. Okay. So this is your motor. Which one here? This is the motor. So the voltage across the motor is E naught, and this is EB, LA or A. Now am writing myself. This is the reference direction. Okay, this red color I'm writing. So E naught is the reference polarity, and IA is the reference polarity. See, reference polarity in the sense when you think the machine is running as a motor. Now you see yourself how we will do now. Okay, this is D3, this is S4, this is D4. Okay, so now you see. See, now actually this is the 4 quadrant chopper. So now I will show you how we will use this chopper to run the motor in all the 4 quadrants. Now before this, I want to explain you this thing. Last class, I have explained you something important in the last class, that in the first quadrant, the second quadrant, third quadrant, fourth quadrant. I think I have given you this thing that in the first quadrant, if I am not wrong, then here in the first quadrant, okay, this you have taken it as speed and this you have taken it as torque. Okay, so y-axis speed, second x-axis torque you have taken. So in this case, it acts as a motor, and we are giving this as forward motor. Please recall this. I explained last class. So now this is forward braking. This is a reverse motoring, whereas this is reverse braking. So third and fourth we call it as reverse. First and second quadrant we call it as forward. Why it is? First and second quadrant is n is one direction, whereas third and fourth quadrant n is negative. So that's the reason that we call it as reverse. Now first and third we call it as motoring. Why? Because n is positive, t is positive, so power is positive. Here n is negative, n is negative, t is negative, so power is positive. So as the power, wherever the power is positive, that is motoring. Wherever the power is negative, that is braking. So one direction you call it as forward, the opposite direction you call it as reverse. So based on this, I think I have explained last class itself. This is in case of, see, this is in case of what? This is in case of a motor. So see here, very simple. You want to operate motor, you want to operate the DC machine as a forward motoring, then you better operate in the first quadrant. Second quadrant, that you want to operate as a forward braking, in the sense you are moving in the same direction. You are moving in the same direction, but you want to use that, you want to slow down. You are moving in the same direction, but you want to slow down. Then that is the second quadrant. That is forward braking. Now in the reverse motoring, in the sense you want to move in the opposite direction. That is, see here, you want to drive the vehicle in the reverse direction. So when you drive the vehicle in the reverse direction, and that too as a motor, So in that case also it takes power, but it travels in the opposite direction. It travels in the opposite direction. Now what is the reverse braking? In the sense you are moving in the reverse direction, but in the reverse direction you are slowing down. In the reverse direction you are slowing down. Here in the reverse direction you are accelerating. Here in the reverse direction you are slowing down. That is declarative. Here in the forward direction you are accelerating. Here in the forward direction you are declarative. So these are the things. Slowly you can cope up with that. There is no problem with this. Okay, so these are the four possible operations of any vehicle. These are the four possible operations of any vehicle. Now, what exactly we are doing now here is that using this four quadrant chopper, I will write here four quadrant chopper. Using four quadrant chopper, please see here. Using four quadrant chopper, we can run the motor in all the four quadrants. That is the advantage of the chopper. That's what I want to say at the end of this explanation. That see, the motor has this application. What are the applications of the motor? You see here, either you can go in the forward direction, you can accelerate, or you can slow down in the forward direction, or you can run the vehicle in the reverse direction and you can speed up in the reverse direction, or the fourth possible is that in the reverse direction you can slow. These are the four possible operations of any driver. These are the four possible operations of any driver. Now, using the help of this four quadrant chopper, we can force or we can run this motor in all the four quadrants. That's the advantage of the four quadrant chopper. Now we'll show you in the four quadrant chopper. Okay, which switches will turn on for which quadrant, that I will tell you. You take first the first quadrant. Okay, so now you see, uh, now you see first quadrant. So see, only thing is that what is the common for this picture and for this picture is that, see, here the y-axis speed, here the y-axis e naught, here the x-axis is torque, here the x-axis current. But I will tell you what is the common thing here is that power is the common thing. You see yourself, multiplying x-axis and y-axis, what you will get? Multiplying the speed with torque. Okay, what you will get? You will get power. Here also multiplying x-axis with x-axis, y-axis, what will get? Power only. So the power is common thing here in both these pictures. The picture number one for the motor, the picture number one for the mechanical parameters, the picture number two for the electrical parameters. So for both the pictures, the common thing is that power. What is the common thing here? Multiplication of y parameter and x parameter. Here also multiplication of y parameter, x parameter. Power is common. So first quadrant power is positive. Here also first quadrant power is positive. Second quadrant power negative. Second quadrant power negative. Third. So likewise you can have the similarity between the electrical and mechanical parameters. Okay. Now you see here. So if you want to operate the motor in the first quadrant, if you want to operate the motor in the first quadrant, It means in the forward motor in direction, what you have to do here, is that your E naught and IA should be positive. So when E naught IA should be positive, then out of all the four switches and all the four diodes, which one will conduct and when? That I will tell you. See here now. First quadrant. So to run the first quadrant, what we do is that, okay. So I will write here itself. Okay. Uh, First thing is that switch 1, switch 4 will conduct. See, I will write here quadrant 1, first quadrant. In the first quadrant, first you turn on S1 and S4 are on. So when you turn on S1 and S4, please see here what is the direction of current, what is the polarity of the voltage. When S1 and S4 are on, what is E naught? E naught will be, see here, E naught will be EA. It's very simple to understand. E naught will be EA. E naught will be EA. And what is IA? IA will move from, I will write here, left side to right side. Or I will write, rather than writing left side to right side, I will write positive. Why I am writing positive is that, what is meant by positive here? Positive means that this reference direction. Which one? That is from left side to right side. You see yourself, when the switch is S1 is on, then S4 is on, then this EA will be there. So EA current will flow like this. Am I correct or not? EA will flow like this way. EA will flow like this. Okay. EA will flow like this through S4. EA will flow like this. Yes, that is when S1 and S4 are on. Now, what I do next is that, I will turn off S1. S1 is off. So if I turn on S1, what will happen? If I turn off S1, then the current which is there in the inductor, which is flowing from left side to right side, that is in the reference direction, will force. What it will force now? It will force, you see here, it will try to continue in this direction, because the inductor force the current to flowing from left side to right side only. So it will flow like this, it will go like this, and it will flow through S4, because S4 is already conducting. You are only turning off S1, please remember. So S4 is already conducting, then it will go like this, then it will turn on D2, or it will force D2. Then after D2 it will go through the motor. So I will write here what is the direction of the current in the first case is that EA S1, EA to S1. Then I will write, what should I write here? Yeah, I will write RA, LA, EB. Okay, this is the direction from EA to S1 to RA, LA, EB, then S4, then EA. That's it. So it makes a closed path. Please see here, it makes a closed path. Okay. Second one. So second one, when S1 is off, what is the closed path when S1 is off? When S1 is off, RA, LA, EB, then S4. Okay, then S4, then D2. It will force D2. Why it will force D2? Because the current direction has to be in the same direction. So it has only one option. What is the option left now? The option, what is the only option left is through D2 only, not through EA. Why not through EA? Because if you think that through EA it is flowing, then S1 is off, D1 is reverse bias, S3 is off, D3. So you have only one option. What is the option left now? Through D2. That is the only option left now. Through D2, then after D2, once again RA. It makes a closed path. So in this case, what is E naught? E naught is equal 0. I will tell. Why E naught is 0? Because it is flowing through S4, which is short circuited, and it is through D2, it is also short circuited. So E naught is 0. But what is IA? IA will be in the same direction, that is positive. Now please see yourself. You please see. In the quadrant number 1, when S1, S4 are on, E naught is equal to EA, and the direction of the current is IA is positive. When S1 is off, then you have seen E naught is equal to 0 and IA is positive. So if you take the average of E naught, E naught is positive and IA is positive. So both E naught is positive, IA is positive, in the sense it is called first quadrant. So you can operate in the first quadrant. So I will write here S1, S4 will be on. Okay. and in second case S1 is off. That's the first quadrant. Okay. Now we'll go to second quadrant. I will take some other color. This color. So quadrant number 2. Now you see quadrant. So you want to operate in the second quadrant. So if you want to operate in the second quadrant, which switches you will turn on? Okay. So which switches you will turn on in that? See here. So which switches you will turn on is that? You turn on CH2. I will write here. Or you turn on second channel in the second switch. So S2 is on. Okay. Now you see when S2 is on. When S2 is on. Okay. So what is the direction of the current? I will tell you here. I will tell you here. S2 is on, so it flows like this. Then it flows through the motor. Then it flows. Sorry, I have drawn in the opposite direction. So because the current gets reversed here, you must understand here that when S2 is on, you want to operate in the second quadrant. Then S2 is on. You see here S2 is on, so it flows like this. It flows like this. Then through this. Then through D4. Then through the motor. Okay, so it makes a closed path like this. I will write the closed path here. I will write the closed path here. I will write here when S2 is on. What is the direction? I will show you the direction here. S2, D4, okay, EB, LA, RA, and S2. You see the reverse direction. Reverse direction. So what is E0 now in this case? What is E0? E0 will be 0. Why E0 is 0? Please see yourself. Why E0 is 0? Because it is circulating like this. Just it's circulating like this when the switch S2 is off. It is circulating like this. So the current, now you see the current gets in the opposite direction. That is from EB, LA, RA. EB, that's the reason I put here EB, LA, RA and S2. So IA I will write here. IA is negative. IA is negative. Okay. Then what sex is now? You see. I will turn off S2. S2 is off. When S2 is off, I told you already the direction of the current will not change. So EB, LA, RA, this will remain same. Only thing is that I turn off S2. So when I turn off S2, the current which was flowing earlier like this, okay, how it flows now is that, see here, the current which was flowing earlier like this, it will take a path through D1. Okay, so it will take a path through D1 and through EA. So D1, after D1 through EA. Okay, then see the colors you can easily understand. I'm changing the colors here every time. So then once again through this, then D4, then EB, LA, RA, D1, EA. So this direction. So this direction. You can say like this. This direction. I have done. Better I will write here so that you can cross check yourself. So this direction remains same. After RA, where it goes to D1. Then after D1, where it goes? After D1, it goes to EA. After EA, it goes to where? After EA, it goes to D4. Then EB. Then makes a closed path. See here. What you must understand here is that this EB-LA sequence is there. Here also EB-LA RA sequence. That will not change because the inductor current does not change its direction. Okay. So here also you see now. Same thing here also. Please see here. In this case also, that this RA-LA-EB is there. Here also RA-LA-EB is there. So this direction of the current does not change. Here also same thing. EB-LA-RA. Here also EB-LA-RA. But it takes another path because you turn off S2. So D1 EA, D4 EB. Now you see yourself. When it takes this path. Okay. So when it takes this path, what is E0 here? So I think it's better. I I will redraw the circuit every time. First quadrant number one, quadrant two, first quadrant chapter. So when first quadrant chapter, I told you that you have two circuits. What are the two circuits? S1, then RA, LA, EB, then S4. So S1, S4 plus minus E naught. Okay, plus minus E naught. So this is first. This is when S1, S4 are on. Now second case is that S1 is off. When S1 is off, what is circuit diagram it becomes? The circuit diagram becomes something like this. It will take through D2. This is what I mean to say here. Yeah, it will take through D2. This is the closed path. Here, this is the closed path. The closed path. So in this case, what is E naught? E naught is equal to EA. EA. So the direction of the current is from left side to right side. It is also from left side to right side. But what is E naught in this case? E naught in this case is 0. Yeah, it's better I will do like this. So in that case, you see now, E naught is either EA or 0, whereas IA is positive. I think with this, we can say it is first quadrant. Now second quadrant, quadrant
So
2. Yeah, please tell.
before switching to quadrant 2, do we reset all the switches, sir?
Do we reset?
All the switches.
Yeah, it depends. See, for example, see, I will tell you one thing that it depends. For example, you want to shift from 1 to 2. Say, for example, see, you want to operate in 2. But before you go to 2, you must know that now in which quadrant the motor is running. That you must understand. Yes? Yes, sir.
Yes, sir.
For example, you take it is running in the quadrant number 1. It is running in the quadrant number 1 in the sense S1 is off or S1 S2 are conducting. It means S1 S2 are conducting in the quadrant number 1. I can say like this. Either S1 S4 both are conducting or only S4 is conducting. So in that case, what you do is that, now what is your question is that, do we reset all the switches or not? That's what you are saying.
Yes, sir.
Yes, we will reset. If it requires, we will reset. See now, for the second quadrant, what you require now, you have to turn on S2. That's it. So if you have to turn on S2, then what is the only option that is left now? You have to turn off every switch except S2. S2 is on. Yes, we can. You have to do
Yes.
that. You have to do that. Otherwise, there is no other option. You can say like this. This is a forced commutation. You can say like this. It is forced commutation. So you turn on S2. So when you turn on S2, what is the closed path? I will say here now. What is the closed path when you turn on S2? Is that S2 is here? Okay, S2 is here. So RA, LA, EB, and here I think you have D4. D4 is there. So I will show you the closed path now. This is the direction of the current. Okay, this is S2, this is D4. So D4, S2 will conduct, D4 will conduct, and RA, LA in this direction. So then what is E naught here now? E naught is equal to 0 because there is no source here left. There is no source here left here. So that is first part of the quadrant 2. Now second part is S2 is off. If S2 is off, we will go to that. What we need to understand is that first I will redraw this picture as it is, and I will tell that this is flowing in this direction only. It has to flow in this direction only. When it has to flow in this direction, now you turn off S2 automatically. Then what is the only option it is left is now it will take this path. See here, because at this point you are breaking the path. When you are breaking the path of S2 at this point, then the current will have to take the opposite direction, because you see here now what is the only option it is left now. See here, when you break this S2, it has to go upwards through D1. Why through D1? Why not S1? Because S1 is also off, S3 is also off. The switches, all the switches are off now. What is the only option left is that it has to take path through the diodes only. They will force the diodes only to turn on. So it will force the diode D1. If it force the diode D1, then where this current will flow now? Only one option left. What is that? Through source. Through source. EA. Through source EA. Okay. Then it will go like this. Then here you have D4. This is the closed part. So D1, D4 and RA, LA, EB in this direction. The direction same as the previous one now. But in this case, what is EA? You apply KVL, E naught. If you apply KVL here, E naught is equal to EA. That's it. This is here. So what are the answers you got now? The answers are E naught is equal either 0 or EA, whereas IA is negative. Why negative? Because the direction you see reverse. The direction is reverse in both the cases, here and here. So it is negative. Then in that case, EA is positive, IA is negative. So you can call this as second quadrant, or you can call forward braking. That's it. So the second quadrant. I will go to third quadrant. Quadrant 3. Better I will redraw circuit here. Every time if I redraw circuit, then it is easier for you. So letter 1, 2, 3, 4, everything. Okay, this is the chopper. The chopper. Now in the quadrant 3, in the quadrant 3, we'll turn on 3 and 2. S2, S3 are on. If S2, S3 are on, what is the circuit diagram it becomes? You see here. This is EA. This is EA. So S2 is on. Yes. This one is the closed path. So in this closed path, once again, what you have to do is that you will force the same thing. The direction of the current will be in this direction only. IA, the direction of the current in this only. Now what is the voltage across this? If you apply KVL, you will understand E naught is equal minus EA. Very important. You just check yourself. You just check yourself. That you will force switch 3, switch 2 conduct. Okay. Then what you find out here is that now this is what? This is a reverse. I told you already this is a reverse motoring. Okay. You will force this the switches to conduct and the current will flow in this direction. So similarly, what we do is now S3 is off. If S3 is off, so what will happen is that uh, this current will not change its direction. S3, where is S3? Yeah, this is off. So if this is off, then what is the option? It is left now. S2 is conducting. Then it has to flow through D4. D4 will conduct. So here I will write. Here I will write S2, S3. Here S2, D4. S2, D4 will conduct. Okay. So in this case, what is E naught here? E naught is equal to 0. Okay. So now you see the current flows in the opposite direction, whereas the E naught is either 0 or negative. So E naught is 0 or minus EA, whereas IA is negative. Okay, IA is negative. So that's it. So you will reverse or you will change the switches in such a way that they will conduct in this direction. Okay, so this is quadrant number 3. Okay, this is quadrant number 3. So now you see the last quadrant, that is the fourth quadrant chopper. So in the fourth quadrant chopper, what we do is now, okay. So first S4 is on. If S4 is on, you see yourself now. Only S4 is on. Please see here. So when only S4 is on, then we will not have this thing. S4 is on. The direction of the line. Okay. Plus minus. So it will conduct through D2. So this is E naught. So E naught is equal to 0 this time. So because S4 D2 are conducting. So S4 is on in the sense here. S4 D2 are conducting. No other switch is there. So S4 D2. There is no other option. It is left now. Okay. Because no other switches, no other diodes will conduct. So only option is left is that it will force D2 to conduct. So then this is the direction of the current. So now you turn on S4 off. You turn off S4. If you turn off S4, then this picture let me draw it as it is. Okay, in this direction only. So you turn off S4. If you turn off S4, then what is the only option left now? It has to flow through D3. Then after D3, of course, this D2 is there already conducting. Then through D3, it will flow through EA in this direction. Okay, so if it flows in this direction, then what is E naught here? E naught is output voltage. E naught is equal to minus EA. Okay, so in the fourth quadrant, what we will find out is that IA is positive. What happens to E naught? E naught is either 0 or negative. So it's the fourth quadrant. So in this quadrant, what is the power? Power is negative. Power is negative and IA is positive, whereas your output voltage is negative. So you see here output voltage, the voltage. So you are reversing the something like this. You are reversing the terminals of your armature. So when you reverse the terminals of the armature, so it flows in the reverse direction. Obviously, it flows in the reverse direction. It flows in the reverse direction. So the wheels will flow in the reverse direction, and the power is negative. It means a reverse braking. I will tell reverse braking. Now in the third quadrant, what do you find out in third quadrant? E naught is negative, IA is also negative. So as E naught is negative, it means the input voltage to the motor is negative. The input voltage to the motor is negative. So it moves in the reverse direction. First of all, it moves in the reverse direction. But at the same time, as the power here is positive, so it acts as a reverse motoring. Okay, it acts as so whether it is reverse direction or forward direction, it depends upon the polarity of E naught. It depends on the polarity of E naught. I'm showing here already. It depends on the polarity of E naught. So E naught polarity is negative. So you are reversing the terminals of the armature. So when you reverse terminals of the armature, obviously, so how is it here? Forward braking. Here, forward braking means power is negative. Power is negative, whereas EA is positive. Okay, EA is positive. Here, first quadrant, power is positive. So these are the four quadrants of how do you run the machine in all the four quadrants using the four quadrant chopper.